Hello, my math friends. Here we have a question from Landon talking about hot air balloons and linear equations. Let's get right into each part of this problem and make sure that it makes sense to you. During a hot air balloon festival, data were gathered on the height of a balloon after X minutes. And then we have some data right here, which I've organized into this table right here. Okay. And so what's important to get right here is on your x-axis, your x values, which is your time. We have 0 minutes, 2 minutes, 4 minutes, 6 minutes, 8 minutes, and the corresponding height. So at time 0, right when the clock is about to start, we have that the balloon is 15 meters above the ground. After 2 minutes, it's 85 meters, and so on and so forth. You always want to get your variables in the right column. That is always going to be very important to get the rest of this problem correct. Now that we have our table, let's answer the question in part A. It says, is the rate of change constant? If so, what is the rate of change and what does it represent? Okay, let's talk about some vocabulary. Rate of change is how something is changing versus, so two measurements that are changing in relation to each other. So I'll explain this with a table. That means that after 2 minutes pass, so if we look at this table, we have +2, right? When 2 minutes pass, what happens to the height? It goes up by 70 meters, right? And then another 2 minutes pass, and then we go up by another 70 meters. And you want to verify that this is happening throughout the entire table because the question is asking, is the rate of change constant? And that is a key word. That means that it's always changing the same way. And if you work through the math down this table, you're going to see every 2 minutes, increase of 70 meters. Next 2 minutes, increase of 70 meters. Next 2 minutes, increase of 70 meters. Because that's all the same, then your answer would be yes. It is constant. Okay, I'm going to actually type this. I think it might be a little bit better. So we have yes, constant rate of change. There is a constant rate of change. In plain English, it's every 2 minutes. The height increases by 70 meters. All right, so we want to actually represent that in a mathematical way. And the way we can do that is, if you recall rate of change, it's basically the slope of a line. And because it's constant, that means that if we were to graph these points and connect the dots, we would get a straight line. And so we'd have, so every 70 meters that goes up, so it's rise, we do our y values first. We have 2 minutes that pass. When we simplify that, we're going to get 35 meters over 1 minute. In other words, every 35 meters per minute. Okay. So what is the rate of change and what does it represent? It represents that the balloon increases at a rate of 35 meters per minute. Again, always put your y value change on the numerator and your x value change on the denominator. Simplify and then put it into the context of this problem. So because 70, the numerator represents my meters and the bottom represents my minutes, we can say 35 meters per minute, and it's positive, so it's going up. That's why we say the balloon's height increases. All right, that is part A, interpreting the rate of change. Part B, we have write a linear equation in slope-intercept form to model the situation. So here we have slope-intercept form. You should have this memorized. It's y equals mx plus b. We now need to fill in the blanks for m and for b. So if you recall, m is your slope and b is your y-intercept. So one of the ways to find this is just start plugging in what you know. And what we do know here is if we have y equals mx plus b, well, y equals, okay, I have my rate of change. Or remember I mentioned earlier, rate of change is slope. So we have 35 over 1, or simply 35 x plus b. Now we need to find the y-intercept, and we can actually see this from the table. I'll write the answer out and explain how I got that. It's going to be plus 15. Your y-intercept is always your starting point at 0. So if we look at our table, at 0, my starting height is 15 meters. In any linear equation, that value of b, this number here, is always going to be your starting point, or whatever the value is at 0. So if you can see it from the table, just pull that information from there and you're done. If not, there is a mathematical way to do that, but we don't have to do that here, and so we won't get into it. And there you have it. That is the slope-intercept form to model the equation. Okay, next part is part C. If the balloon continues to rise at the same rate, use function notation to express the height after 12 minutes. Now, what I want to talk about here is function notation. When you get into higher level math, you will start writing things in terms of f of x. So for example, instead of saying y equals, we're going to say f of x equals 35x plus 15. This is what we call function notation. It's really just writing the y as an f of x. Now I want to clarify this. That doesn't mean f times x. It's read f of x. And what that means is if I decide to plug in a value for x, now this question asked to express the height after 12 minutes. Remember, your x value or is your time, right? So if we say f of 12, but what you're saying there is not f times 12. You're saying, what is my height when I plug in 12 for my time? Okay, so then we're gonna replace each x with 12. You're basically in function notation being told what to plug in for x. So whatever number is here, that's what I want to plug into my x values wherever you see them in the equation. Now when we solve this, we're going to get 35 times 12 is 420. Let me get back to this. 420. So let's write this as f of 12 equals 420 plus 15, and the final answer, f of 12, equals 420 plus 15 is 435. And so in plain English, that means when 12 minutes pass, the balloon is 435 meters off of the ground. Okay, so you got to be able to interpret that and what that means. That is the answer to part C. Express the height after 12 minutes. So the height is 435 meters. Okay. And finally, part D. We have, let's see here. It says, provide the domain given that the maximum height is 500 meters. Okay, so the maximum height allowed is 500 meters. We're going to go back to our equation and we're going to write, all right, we're going to say, and we can use function notation or with the y and x's. It really doesn't matter at this point. I'm going to use the y and x's because it's a little bit easier to understand. So if you recall from the beginning, I said always know what your x and y's are. We know that height represents our y values, right? And I know that because I put the height in the y section of my table. And that's very important because you want to know where you're going to plug in what. So if they're saying my height should be 500. Where do you think I should replace the 500, the X or the Y? The Y, because it's my Y column that represents height. So we're going to say 500 equals 35x plus 15. And we're going to solve, just regular solving equations. We're going to subtract 15 from each side. And we get 485 equals 35x. And then let's divide out the 35 from both sides. 485 divided by 35 equals approximately 13.86. Let's round it to the nearest hundredth. And what does that mean in this context? Well, what does X represent? X represents time. So after about 13.86 minutes, the balloon reaches its maximum height. The max height of 500 meters. We're almost done with this part D. The question was asking for the domain. Domain in math means all of your possible X values. So here, what are our X values? It's our time column. So basically, what is the lowest time measurement that we can have in here? And what is the highest time measurement? So because time can't be negative, obviously, our domain would start at 0, okay? 0 minutes, right? And so we're going to say, okay, my domain starts at, and we're going to use a hard bracket, 0 minutes, and the maximum time would be 13.86. And the reason it's 13.86 is because this problem told us that the maximum height allowed for this balloon is to reach 500 meters, and that happens at 13.86 minutes. There you have it. Hope that makes sense. Feel free to contact me if you have any other questions.